Byrne Tool and Design, small to medium-sized injection molds, mold tooling for electronics components, among other things. So Mark, why don't you describe your 3D printer real quick?
Okay, we actually have two 3D printers from Stratasys. Our first printer that we got was an FDM printer, which is a 250MC, which uses ABS filament to build up the layers. The layer thicknesses can be 7 thousandths, 10 thousandths, or 13 thousandths thick. The second printer that we got is the Stratasys J750, and this uses a liquid resin and a UV light to cure the parts. Now, the layer thicknesses on that can be around 28 microns.
So, Mark, you use 3D printing for prototyping, but I'm also aware that you do some one-shot molds also. You have a customer where getting UL approval for their new parts is very important, and the one-shot 3D printed molds allows you to be a lot more efficient about that. So talk about that.
Yeah, this is a really unique opportunity because our customer will kick us off on two molds at the same time. They will kick us off on a production steel mold, and they'll also kick us off on a 3D printed mold. The 3D printed mold, we can actually have it designed, reviewed, and printed within a day or two. Right after that, they will put that into the press and start shooting their parts. Then they take the parts, build up their assemblies for UL compliance, ship it to UL, and roughly around the same time they get the feedback from compliance that it passed, our steel production mold is complete at the same time. So this allows our customer to get to the market 6 to 8 weeks faster.
So you brought some pictures of tooling that 3D printing is helping you attain. So in a few minutes here, let's quickly advance through a few of those.
Okay. Here's just a real simple one. It's a little milling fixture for milling out the bottom of an extrusion. So we just designed this to have little pockets in it so we could adhere some magnets to it, and it just fits into a clamp that opens and closes. So the CNC operator can open up the clamp, set the workpiece in and index it, close it, and start milling some of the parts. Now with a nice plastic material, it doesn't mar the part at all. Another fixture that we did here is a little bit more creative. Our customer actually has a mold that can do all the different configurations for this part. And what I mean by configurations is a whole bunch of holes on the top of the black part. Now, they don't want to inventory all of these holes and all these different parts, so what they do is they mold a blank. So with this blank part, as you can see in the picture on the left, they actually take the part, set it into the keyed nest, and the sides actually fold over to secure the workpiece in the Z direction. Then they put that into their clamp and start milling whatever configuration they need. Now we also do a different approach here for a hybrid conformal cooling. This part that our customer is molding is a large cylindrical part with a kind of a capped end on it. Now they wanted conformal cooling in here, but we had a long lead time for cutting this out of steel. So we had a partnership with our customer that, okay, let's try printing this out. So what we ended up doing is printing this out, inserting it into a steel sleeve, and installing that into the mold. And you can kind of see on the picture on the right hand side, there are actually two holes going all the way through the part. The center hole is designed for an air pocket, and the hole on the right is designed for an ejector pin, which is connected to an RJG sensor. We also had one of our customers who wanted to add RJG sensors to their mold. Instead of going out and getting a block of aluminum and having it machined out just so we can hold the RJG connectors, we actually designed it and printed it out. There's no load on these parts or anything, so we actually use it in production sometimes for our steel molds. Now this one's a little bit interesting. One of our customers was having a Christmas party with employees coming over and a bunch of little kids, so they wanted to actually give away a little toy for all the kids. So they wanted to give them a toy airplane. Now this airplane was actually designed with a press fit construction. So what we ended up doing is making a 1+1 printed mold for this. And you can see on the picture on the right hand side, we actually used a tapered ejector pins to create that small press fit boss. Now, when we usually do our molds, what we like to do is we also like to print out an ejector plate. So after the part's molded, we can pull it off from the press, align our ejector plate with the ejector pins, and tap it a few times with a hammer, and our parts pop right off. And this is a situation which I kind of mentioned before. This is a switch button that one of our customers wanted for UL. So they kicked us off on the prototype mold and the prototype mold and the production mold at the same time. This one was a little bit different because the part actually had undercuts in it. So we had to design and print out some hand loads on it. So what we do is just basically we like to use some steel dowel pins to line the two mold halves together. And we also built another ejector plate for this. So when you pop out the parts, all that you have to do is whack it with a hammer, and it also pushed off the hand loads. So the part is now out of the mold with the hand loads in it. Just separate those, and the part's ready for UL testing. And our customer actually, it sped their time to the market by 7 weeks for this example right here.
Perfect. Thank you, Mark.
Thank you.